Hey everyone, this is the Math Nexus, and today we are going to start with chapter 4 for O level and IGCSE additional mathematics. As you may have noticed right now, I have changed the thumbnail and specifically I've changed the book for which we are going to follow uh, the sequence. And the reason for that is because I want these lectures to be as helpful to people as possible. So if I cover the previous book, it's going to be limited. And the reason why I switched right now is because, the first two chapters are exactly the same. And then indices and inserts is not there. So that's an extra chapter. So, and in this book, the third chapter will be our polynomial equations. So there's not much of a difference here. The first two exercises will be same, and the chapter 3, which is the indices inserts previous chapter, is going to be just an explanatory session so that people can review what they're weak at. So I hope that clarifies the concept, and we're going to go on with the third edition of Sue Pemberton's book. I don't know if that name is pronounced right or not, but yeah. So we're going to go with that. Before we start with this chapter, which is chapter 3 in the new book, we can see what are polynomial equations. So polynomial equations are basically anything which have an unknown. Okay, so what do you define as an unknown? Well, it can be x. Okay. It can be x squared and x or whatever it can be. It's the unknown is actually specified in the question. Okay, so be aware of that. And one common mistake I see people confusing is, for example, I have ax plus b, where a where a and b are constants, while x is an unknown to be found. Okay. One common mistake is that people think that x and b will be something different. Well, that's not the case. Yeah, for one specific time, the value of x can be the same, but there's a difference between a variable and a constant. So basically, constants, which are going to be this a and b, they're basically values which are going to be, they're basically just numbers. For example, if I would have written this as 5x plus 3, this would correspond to a and this would correspond to 3. So basically, these values are just there in the equation. However, if I go for the x value, it's quite different. And the reason for that is because the x value changes as opposing to the graph. For example, if I draw one graph here, second. Okay. So if I have some line which gives me the equation like this, something like this, and so as you can see, as we proceed throughout the x values, there's a change in the y values. And what is the change? As x is increasing, y is decreasing. Okay. So there's a corresponding change. So x is changing along with y is changing along with x. However, the constant remains the same. Okay. For example, if this graph would have been the graph for 5x plus 3, which it is not, but let's assume for now, the 5x plus 3 wouldn't have changed in any case. However, the x values would have changed, which would have determined our y values. So I hope that clarifies the concept, even if it's not right now. So do let me know. I'll try my best to clarify in the comments. Well, if I cannot, I'm sorry about that. But still, I hope I clarify the concept. And before we go again, one more thing I need to clarify is that you can't ever add x squared plus 3x cubed plus 4x squared plus 4x raised to the power 7 or something. You can't ever do this. You can't ever add this up. You can't simplify this more. Yes, you can factorize this further. If, for example, you take what's the biggest value you can take as a common, you can take x squared as a common. So 1 plus 3x plus 4x raised to the power 5. Okay, so we can simplify it this way, but we cannot further simplify by addition or subtraction or whatever case that comes. Yes, we can multiply x squared multiplied by x raised to power 7 would give us the 7 plus 2 is 9, so x raised to power 9. Yes, we can do that, but never ever do we add different degrees to each other when they are being added or subtracted. Now, as you may notice, I have used the name degree. So what's a degree? Well, degree is basically, if I were to define degree, I would say degree
So there's so there's so there's
is
there's
the highest
so there's so there's so there's so there's so there's so there's so there's
power
so there's so there's
of x
so there's so there's
in a polynomial.
so there's so there's so there's so there's so there's
Polynomial
so there's
equation.
so there's
And
so there's
basically, I hope you understand what that means. And that means that whatever the greatest power of x will be in a polynomial equation will be called a degree. So for example, right now I have 4 here as the greatest power, as you can see. So this type of equation will have a degree of 4. Okay. This type of equation will have a degree of 4. And we call it quadratic equations. Right now, it's not really important for you to know anything above the degree of 4, as it's not into the AddMaths syllabus. So chill right now, okay? Then we have something like ax cubed. So what's the highest degree here? It's the degree 3. And what do we call that? These kinds of equations, we call them cubic equations. Now, another thing to remember is it's not necessary at all that, for example, if you have x cubed plus 1. Sorry. So this would also be called a cubic equation. And that's basically because the highest value of x is 3. Okay, the highest degree. Or you can say the highest power of x is 3, which is called the degree. So I hope that clarifies the concept, but it's not necessary. Just remember that whatever the highest power of x, or in fact any unknown, because an unknown could be x, it could be y, it could be z, or whatever you want it to be. An unknown is an unknown. So basically, whatever highest power your unknown has is called the degree. So the highest power of x for which it is 1, we call this those linear equations. As you can see, this is also a linear equation. So then we have ax squared plus bx plus c. This is a quadratic equation, and we have discussed quadratic equation in great detail in previous chapters, which come in this way or in this way. I won't go into details about this cubic equation. I'm just telling you these things so that you can have a good visualization concept. And for cubic equations, you have something like this of a graph. So that's basically it. We'll go on to the problem solving part so that you can take questions. Okay, so this is the first question we are doing from the new AddMaths O-Level and IGCSE book, which is the third edition book. Okay. Now for question number 1, we have px. Let's just copy down the things first. Px is equal to 3x raised to the power 4 plus 2x squared minus 1. And qx, I'm going to go and elaborate this much more than I should, because this will be the first question. So I'm going to elaborate as much as possible. X squared plus 1. In fact, I'm going to raise this so I can have more space to work with. Yeah. So they've given two expressions, and as we can see, what would be the highest power of x in the first expression? It's obviously 4. And for the second one, we can see clearly that it's 3. And if we were to go up here, so what was the 4 and 3? Quartic and cubic equations. So as you can see, we can clearly say that this is a quartic equation, and this is a cubic equation. So we have two expressions. Now what they've told us is to add them up for part A, which is part A, they have told us to add px plus qx. Now again, simple as that. I'm going to just copy down these first of all. So 3x raised to power 4 plus 2x squared minus y. Now, one thing I prefer doing is, and I suggest you to do, is trap any equation in a bracket when you are inputting any value into another equation. For example, this is y is equal to 2x, so and x is equal to 3. So always put a bracket here, because you never know when you have a negative sign and which sign just changes. You never know, because if you do not add brackets, you are more prone to making mistakes of addition and subtraction. Okay, I hope that clarifies it. Now add this into qx, which is 2x cubed plus x squared plus 1. Okay, now we're going to just follow this down because there's no change here. 2x squared minus 2x squared minus x squared plus 2x cubed and then minus 1 plus 1. Okay, so now we're going to copy this down in descending order. Again, it's essential. It's not essential, but it's better. It's much more, presentable if you just go with a descending order of powers. So it's better if you write in descending orders of powers. So we have 2x cubed, then we have what? We have nothing. Then we have 2x squared, and we have another x squared minus 1 plus 1. Then we can go with 3x raised to power 4 plus 2x raised to power 3 plus 3x cubed, 3x squared minus 1 plus 1 cancels down, and that's equals to your answer. For part B, we have 3px plus qx. So basically now we have 3px plus qx. Let's make partition over there. It's going to be much more better. So 3px plus qx, that would be equals to 3 multiplied by what is px. This is equals to 3x raised to the power 4 plus 2x squared minus 1. Again, in brackets, as you can see, it's essential right now. Plus qx would be 2x cubed plus x squared plus 1. Okay, so we have got 3 3s is 9, x raised to the power 4 plus 3 2 is 6, x squared minus 3 plus 2x cubed plus x squared plus 1. Okay, so 9x raised to the power 4 plus 2x cubed. Cancel this down. Plus 6x squared plus x squared. Just going to write this as it is, 7x squared. Minus 3 plus 1 is going to be minus 2. So this is basically your answer for part B. 9x raised to the power 4 plus 2x cubed plus 7x squared minus 2. Now for part C, we have px minus 2qx. So px, you're going to copy down as it is 3x raised to the power 4 plus 2x squared minus 1. Now that's where the power of bracket comes up. So minus 2 multiplied by qx would be what is qx? 2x cubed
So there's
plus x squared plus 1. Now you can further simplify this up. We have
so there's so there's so there's
3x raised to power 4 plus 2x squared
so there's
plus 2x squared minus 1
so there's so there's
minus 2 to the 4x cubed
so there's
minus 2x squared
so there's
minus 2. Okay, so we've got 3x raised to power 4 cancels this negative 4x cubed.
so there's
This 2x squared minus 2x squared is cancelled down to give 0, negative 1 minus 2 is negative 3. So 3x raised to the power 4 minus 4x cubed minus 3 is equals to your answer.
so
For
there's
part D, we have px multiplied by qx. And now this is an interesting thing because if I were to do this, px is 3x raised to the power 4
so there's
plus
so there's
2x squared minus y.
so there's
2x squared, 2x cubed plus x
there's-
squared plus 1.
so there's
Now
so
the
there's
thing is, till now we knew how to multiply two linear equations. For example, 2x plus 1 and 3x plus 2. We could multiply this by the FOIL method. However, this is not the case in this terms.
so there's
So what we have to do is we have to do a pretty, labor-intensive job of multiplying each term by each term in the second bracket. So basically, we multiply 3x raised to the power 4 multiplied by 2x cubed plus x squared plus
so
1.
there's
And then we plus 2x squared here multiplied by 2x cubed plus x squared plus 1. And then minus 1 here multiplied by 2x cubed plus
so there's
x squared plus 1. And now we basically have to simplify this. I know it's kind of hard, but there's no other method that I know of in
there's-
O-level AddMaths that should be able to solve this. So that's your only option. So 3 to the 6,
so there's
x 4, 5, 6, 7 plus
there's- so there's
3 x raised to the power 4, 5, 6 plus 3x raised to the power 4 plus 2 to the 4x to 5
so there's
plus 2x raised to the power 4 plus 2x squared minus 2x cubed minus x squared minus 1. Simplify this further, we would get 6x raised to the power 7, then we would have the power of 6. Let's compare the values. There's only one power of 6 here, so 3x raised to the power 6. Then we have 4x raised to the power 5. And is there any other value of raised to 5? So plus 4x raised to the power 5.
so there's
And then we have 4. So 3x raised to the power 4 plus 2x raised to the power 4 is going to give us 5x raised to the power 4, which will be written here. 5x raised to the power 4. And then we have raised to the power 3. So negative 2x cubed.
so there's
Then
so
we
there's-
have 2x squared minus x squared. So this is plus x squared
so there's so there's so there's so there's
minus 1.
so there's
Okay, and that's it. This is actually your answer
so there's
for
there's-
part B.
there's-
6x raised to the power 7 plus 3x raised to the power 6 plus 4x raised to the power 5 plus 5x raised to the power 4 minus 2x cubed plus x squared minus 1.
so there's
And
so
that
there's-
is it for question number 2.
So there's-
Raise this up for question number 1.
so there's so there's
Use
so there's so there's so there's so there's so there's so there's
Okay.
so there's
So for question number 2, what we're going to do is first copy this down. 2x minus 1 multiplied by 4x cubed
so there's
plus x plus 2. Again, both of these brackets do not have two terms in them, so we have to do the labor-intensive job of multiplying each of them individually. So 2x multiplied by 4x cubed plus x plus 2 minus 1 multiplied by 4x cubed plus x plus 2.
so there's
Then
so
we
there's-
have Gotuza is 8x raised to power 4 plus 2x squared plus 4x minus 4x cubed
there's
like minus x minus 2. Solve this further. 8x raised to the power 4 is the highest value. Then we go on to 2x. In fact, we go on to negative 4x cubed. Then we go to 2x squared. Then we go to 4x minus x is going to give us 3x. Positive 3x minus 2 is equals to answer. So this is basically your answer. 8x raised to the power 4 minus 4x cubed plus 2x squared plus 3x minus 2. Proceeding on to part B. So part B is x cubed plus 2x squared minus 1 multiplied by 3x plus 2. Now again, individually multiply each and every one of them. What I do is just write this down. 3x multiplied by x cubed plus 2x squared minus 1 plus 2 multiplied by x cubed plus 2x squared minus 1. Okay, so we are going to continue with this 3x raised to the power 4 plus 6x squared. In fact, 6x cubed minus 3x plus 2x cubed plus 4x squared minus 1. Now simplify this 3x raised to the power 4 plus 6, 7, 8, 8x cubed. Cancels down, this cancels down, minus plus 4x squared minus 3x minus 1. So that's basically your answer for question number 2, part B. Proceeding on to part C, we have 3x squared 3x squared plus 2x minus 5. Then we have x cubed plus x squared plus 4. Again, we have to multiply each of them individually. X cubed multiplied by 3x squared plus 2x minus 5 plus x squared multiplied by 3x squared plus 2x minus 5 plus 4 multiplied by 3x squared plus 2x minus 5. Let's simplify this. 3x raised to the power 5 plus 2x raised to the power 4 minus 5x cubed plus 3x raised to the power 4 plus 2x raised to the power 3 minus 5x squared plus which is as 12x squared. Continue here, in fact, plus 12x squared plus 4 to the is 8x minus 4 5 is 20. Now simplify this equation, we get 3x raised to the power 5. That down. 2x raised to the power 4 plus 3x raised to the power 4 is going to give us 5x raised to the power 4. Then we have negative 5x cubed plus 2x cubed will give us negative 3x cubed. We're going to write that down, negative 3x cubed. Then we have 5x squared and 12x squared. 12 minus 5 is going to give us positive 7x squared. And then we have plus 8x minus 20. And that is your answer. Let me just recheck it for once. 3x raised to the power 5 plus 5x raised to the power 4 minus 3x cubed plus 7x squared plus 8x minus 20. Yes, that is the correct answer. Okay, for part D, we have x plus 2 whole squared multiplied by 3x cubed plus x minus 1. Okay, so again, this, as you can see, this is in a squared form, so we can't just directly multiply this. You have to simplify this further. For that, what I'm going to do is, this is my quadratic method for a squared, which is x squared, plus 2 multiplied by a multiplied by b plus b squared, which is 4, multiplied by 3x cubed 3x cubed plus x minus 1. Okay. So the next thing I'm going to do is x squared plus 4x
so there's
plus 4
so there's
multiplied by 3x cube plus x minus 1. Okay. Now I'm going to multiply each of them individually. X squared multiplied by 3x cubed plus x minus 1 plus 4x
so
multiplied
there's
by 3x cubed
so
plus
there's
x minus 1 plus 4 multiplied by 3x cubed
so
plus
there's
x minus 1. So
so
we have
there's
3x raised to power 5 plus x cubed minus x squared plus 4 3 is 12 x raised to power 4 um, plus 4x squared minus 4x
so there's
plus 4 3 is 12 x cubed plus 4x minus 4. Okay,
so there's
that simplifies it to 3x raised to power 5. You get this down. Then we have 12x raised to power 4 and nothing else. So plus 12x raised to power 4 plus
so
x
there's
cubed plus 12x cubed would give us 13x cubed.
so there's
So plus 13x
so
cubed
there's so there's so there's
minus x squared plus 4x squared is going to give us positive 3x squared. So
so
we have
there's
got positive 3x squared.
so there's
And then we have negative 4x plus 4x, which would be 0. So not writing it here. So negative 4. And that is your answer.
so
So
there's
your answer is 3x raised to the power 5 plus
so there's
12x raised to the power 4 plus 13x cubed plus 3x squared minus 4. And for part E.
so there's so there's
For part E, we have something like x squared minus 5x
so there's
plus
so
2.
there's so
And
there's
again, we can't use, oh, sorry, we do also have a square. So now we can't use the quadratic formula, which would be a squared plus 2ax
so there's
plus 2x. What? Sorry, a squared plus 2ab plus b squared. Okay, so this won't be applicable over here because we have something more than a. Because if this would be a, this would be b, and this would be something else. So we can't use the quadratic formula. Short things short.
so
What
there's
would we do? So we know already that square means double of something. Meaning, if I would say 2 squared, it's practically equal to 2 multiplied by 2. If I'm saying 3 cube, it's going to be 3 multiplied by 3 multiplied by 3. So the power tells how many times your number is basically multiplying by each other. So
so
x
there's
squared minus 5x plus 2 is going to multiply by x squared minus 5x plus 2.
so there's
Now we can multiply them individually with each other. So x squared multiplied by x squared minus 5x plus 2
so there's so there's
minus 5x multiplied by x squared minus 5x
so
plus
there's
2
so there's
and plus 2 multiplied by x squared minus 5x plus 2.
so there's
So we
so
have
there's
got x raised to power 4 minus 5x raised to power 3 plus 2x squared minus 5x raised to power 3 plus 5 5 to 25x squared
so
plus,
there's
in fact, minus
so there's
5 to the is 10x plus
so
2x
there's
squared
so
minus
there's
5 to the is 10x
so there's so
plus
there's
4. Now simplify this, we get x raised to power 4
so there's so
minus
there's
5x cubed minus 5 is x cubed is give us negative 10x cubed. We'll copy that down here. Negative 10x cubed
so
plus
there's
2x squared plus 25 would give us 27x squared. 27 plus 2 is 29x squared plus
so there's
29x squared and then minus 10x
so there's so there's
plus 4 is equals to your answer.
so there's so there's
I hope that is clear. So just
there's
recheck this up. X raised to power 4 minus 10x cubed plus 29x
so there's
squared minus
there's
20x plus 4. And I do have a problem here. What is the problem? Yes, I forgot one negative 10x. So this would obviously be
so there's
negative 20x. My bad. I'm really sorry about this. So for part F, we have 3x minus 1 cube. And
there's
you know where we are going right now. You already know this. I hope so you know this. And for those of you who don't know,
so there's
you know, to be honest, If you're an AddMaths student, be ready to get yourself,
So there's
to the limit.
so there's
It's not much, it's not hard. If you go into A-level maths, you'll find that AddMaths was easier. So it's step by step. By the time you find things that were harder, are going to be easier to you.
so there's
Okay, so keep up the motivation. So 3x minus 1 cube would mean 3x minus 1 multiplied by 3x minus 1
so there's
multiplied by 3x minus 1. And to be honest, it's not going to be much of a problem if you know how to solve these things. So always remember, take help from shortcuts. If you know shortcuts, 20-minute answers can be solved in 10 minutes. Okay, so if you
So
were
there's
to multiply 3x multiply by 3x minus 1, don't do that. You can use the FOIL method for this first method. So we multiply the first two brackets by the FOIL method because there's only two constituents of it. So we're going to say 3x multiplied by 3x, which is the first term. So 3 3 is 9, x squared. Outer term multiplied by the outer term, which is minus 3x. Inner term multiplied by the inner term, which is again negative 3x. And the
So
last
there's-
term multiplied by the last term, which
So
would
there's-
be positive 1. Now this would be multiplied by 3x minus 1. And if I were to further simplify this, 9x squared minus 6x plus 1 multiplied by 3x minus 1. And now it's basically the same thing we've been doing before. Okay,
So
so
there's-
now we're going to simplify this to 9x squared minus 6x. In fact, I'm going to just write it as it is right now. 3x multiplied by 9x squared minus 6x plus 1.
So there's-
And minus 1 multiplied by 9x squared minus 6x plus 1.
So
Now
there's-
simplify this. 9 3 is 27x squared.
So there's-
Sorry, 27x cubed.
So there's
This cancels out. Minus 6 3 is 18x
so
squared
there's
plus 3x minus 9x squared
there's-
plus 6x minus
there's-
1. Simplify
there's-
this, we get 27x cubed minus 18 minus 9 is equals to minus 27x squared plus 3x plus 6x is equals to positive 9x minus 1. And that is your answer for question number 2, part F. And that concludes question number 2. Proceeding on to question number 3. Question number 3 tells us to simplify each of these following equations, which is not a big deal because we've been doing this on the starting of this exercise.
So there's
2x minus 3 multiplied by x plus 2
so there's
plus x plus 1 multiplied by x minus 1.
so there's
Again, shortcuts are really important. First of all, what you'll do, because these two brackets have only two constituents, we can just simply do the FOIL method. First multiplied by first value is going to be 2x squared. Outer value multiplied by the outer value is 4x. Inner value multiplied by the inner value negative 3x, and the last value multiplied by the last value is negative 6. Then we go on. X plus 1 multiplied by x minus 1. So a plus b multiplied by a minus b. We already know this. A plus b multiplied by a minus b. This is an identity. That would be equals to a squared minus b squared. So we already know this. No need to be stressing on this. So we have a squared, which is x squared, minus b squared, which is 1 squared, which is 1. So simplify this to x squared plus 4x minus 3x minus 6 plus x squared minus 1. Simplify this to x squared plus 3x plus x squared would give us 3x squared. Then 4x minus 3x going to give us plus x minus 6 minus 1 is going to give us 7. And that is your answer. 3x squared plus x minus 7 is your answer for question number 3. Okay. For part B, we have 3x plus 1 multiplied by x squared plus 5x plus 2 minus x squared minus 4x plus 2 multiplied by x plus 3. So we have got first value, which is 3x multiplied by x squared plus 5x plus 2 plus 1 multiplied by x squared plus 5x plus 2 minus again x multiplied by. I'm going to give this in a bracket because we have to multiply by this negative also. So again, essential thing, we are subtracting this whole thing from this. Okay, so it's really important to, when you're going to simplify this, just place one bracket. So x multiplied by x squared minus 4x plus 2 plus 3 multiplied by x squared minus 4x.
So there's 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 so
Now we're
there's
going to simplify this. We get 3x squared, which is 3x cubed actually. 3x cubed plus 5 3 is 15x squared plus 3 to the 6x plus x squared plus 5x plus 2 minus, again a bracket, x raised to power 3 minus 4x squared plus 2x plus 3x squared minus 4 3 is 12 minus 12x plus 6. Now we have got, if I were to simplify this a bit, 3x cubed plus 15x squared plus x squared would be 16x squared. And then 6x plus 5x would give us 11x, and then plus 2. Now that's where I was emphasizing the importance of a bracket, because now we'll open this bracket up and we have to multiply this negative by this, this, and all the other constituents of the bracket. So negative x cubed plus 4x squared minus 2x minus 3x squared plus 12x minus 6. Now simplify this. 3x cubed minus x cubed would give us 2x cubed. So 2x cubed here. 16x squared plus 4x squared is going to give us 20x squared. 20 minus 3x squared is equals to 17. So there's positive 17x squared. Then we have 11x minus 2x. So we have got 11 minus 2 is 9. And what is another one? Yeah. So 9. Wait a second, 11 minus 2 and then plus 12. So 12 plus 9 is equal to 21. Positive 21x. And then we have positive 2 minus 6. So we are going to get negative 4. And that's basically your answer for this part. 2x cubed plus 17x squared plus 21x minus 4. Okay, for parts, for part C, what you're going to do is just multiply this. 2x cubed plus x minus 1 multiplied by x squared plus 3x minus 4 minus x plus 2 multiplied by x cubed minus x squared plus 5x plus 2. So this may seem intimidating, but believe me, it's like just one thing you have to conquer, and it's like it's supposed to be a bit, dirty, but it's easy, basically, the concept of what I'm going to say. So basically, we just multiply 2x cubed multiplied by x squared plus 3x minus 4 plus x multiplied by x squared plus 3x minus 4 minus 1 multiplied by x squared plus 3x minus 4. Then we minus here, and inside a bracket we say x multiplied by x cubed minus x squared plus 5x plus 2 plus 2 multiplied by x cubed minus x squared plus 5x plus 2. Inside a bracket, and we close that up. Now simplify this. We've got 2x raised to power 5 plus 6x raised to power 4 minus 4 to the 8x raised to power 3 plus x raised to power 3 plus 3x squared minus 4x minus x squared minus 3x plus 4 minus x raised to power 4 minus x raised to power 3 plus 5x raised to power 2 plus 2x plus 2x cubed minus 2x squared plus 10x plus 4. Okay, so now we have got 2x raised to power 5 here. Then we have got 6x raised to power 4. If you were to simplify this, negative 8 plus x cube is equals to negative 7x cube. And then is there anything else? No, there is not. Negative 7x cube. Then we have got 3x squared minus x squared, which would give us 2x squared. So negative positive 2x squared. Sorry, 2x. Yes, positive 2x squared. Negative 4x minus 3 is equal to negative 7x and plus 4 as it is. Minus, now simplify this, x raised to power 4. X cube can be simplified to nothing. So minus x cube. And then we have got x squared, 5x squared minus 2x squared would give us positive 3x squared. Then we have 2x, 2x plus 10x. This would give us 12x. In fact, I did not write the cube. Sorry, positive 2x cube is here also. Plus 12x plus 4. Now what I'm going to do is simply just arrange, get it out of the brackets. 6x raised to power 4 minus 7x cubed plus 2x squared minus 7x plus 4 minus, now again, this negative sign is going to be multiplying here, 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 and all the other constituents in this bracket. So we are going to say this is going to be equals to negative x raised to power 4 plus x cubed minus 3x squared minus 2x cubed minus 2x cubed minus 12x minus 4. Now simplify this. We've got 2x raised to power 5 here as it is. Then we've got 6x raised to power 4. Then for 7, in fact, not 6x raised to power 4, we've got 6 minus 1, which is positive 5x raised to power 4. Cancel this down here. Then we have cube, negative 7x cube plus 1x cube would give us negative 6x cube. Then we have 2x squared. Minus 3x squared would give us negative x squared. And I think I did a mistake, 7x cube plus x cube. Yes, I did not simplify it all. So this would be negative. Negative 7x cube plus x cube minus 2x. So 7, 6, so negative 6 minus 2 is negative 8x cube. So minus x squared is going to be written here. Where were we? 2x squared minus x would give us negative x squared, and then negative 7x minus 12x would give us negative 19x. Minus 4 positive 4 cancels down. So I think this should be your answer. Our answer is supposedly 2x raised to power 5 plus 5x raised to power 4 minus 8x cubed minus x squared minus 19x. And it is exactly that. So for question number 4, let me just test this up. Question number 4, we have different expressions. Let's just go first. If fx is equals to this, fx equals to 2x squared minus x minus 4 and gx is equal to x squared plus 5x plus 2, find an expression for fx plus xgs and so on and so forth. So basically, there's no big thing. As in the first question, they had given px and qx. Right now, they've given fx and gx. So they've just given two functions, and they have told us perform this thing on that function. We go on this. There's no rocket science to this. Question number 4a is fx. So just copy down fx 2x squared minus x minus 4 plus x gx. So x gx means x multiplied by, and now copy down inside the bracket gx. So x squared plus 5x plus 2. Now if we were to simplify this, I would get 2x squared minus x minus 4 plus x cubed plus 5x squared plus 2x. Simplify this further. 2x squared plus 2x squared is going to give us 4x squared. Then, in fact, we first write cube. So x cubed here, then 4x squared,
so there's so there's so there's so there's
I think I'm doing one mistake. X cubed plus 5x squared plus 2. So we have got x cubed as it is first here, plus 5x squared plus 2x is going to give us 7x squared, minus x plus 2x is going to give us positive x, minus 4 is equals to your answer, and that should be it. Let me just check. X cubed plus 7x squared and plus x minus 4. That is the answer. For B, we have
so there's
fx whole squared. Now,
so there's
fx whole squared means we're going to say x squared, 2x squared
so there's
minus x
so there's so
minus
there's
4.
so there's so there's
And we square it as a whole.
so there's
Okay, so now if I were to square this, I would just simply, again, do the same thing I did previously. Systematic. So 2x squared minus, multiplied by 2x squared minus x minus 4. I've
so
done
there's
this in the previous part. Minus x multiplied by 2x squared minus x minus 4. And then
so there's
minus 4 multiplied by 2x squared minus x minus 4. And
so there's
basically, why I did that is because 2x squared minus x minus 4 would eventually mean 2x squared minus x minus 4 multiplied by 2x squared minus x minus 4.
so there's
Okay, so we are going to go forward. Okay, so right now we are going to multiply by 2 to the 4.
so there's so there's so
2
there's
to the 4 x raised to power 4
so there's
minus 2x raised to power 3.
so there's
2 to the 4x raised to power 4 minus 2x cubed minus 4 to the 8x squared minus 2x cubed plus x squared plus 4x minus 8x squared plus 4x plus 16.
so there's
Hope that's clear. Then simplify this. 4x raised to power 4 is going to be written as it is. And
So
then
there's-
negative 2x cubed minus 4x cubed and nothing else. So negative 4x cubed.
so there's
Then we have 8x squared minus 8x squared, which would give us a 16x squared, negative 16x squared, and plus 1 would give us negative 15x.
so there's
Then we have 4 to 4x and 4x, which would give us 8x plus
So there's-
16. Copy
there's-
this down as it is. So our answer would be 4x raised to power 4 minus 4x cubed minus 15x plus 8x plus.
so there's
Okay,
so there's
I hope that is clear to you all.
so there's so there's so there's so there's so there's so there's
Now proceeding on to part C, which is quite different.
So there's-
squared x.
so
Now,
there's
before we start this, I'm going to explain what this notation terminology means.
so there's so there's so there's
In this partition.
so there's
So basically, whenever you have something like
so there's
x, okay, take that right now.
so
So
there's
fx means that my function is in terms of x, which would give me x squared plus 3x plus 2. So if I were to write this exact equation in terms of a, I would write fa, which would give me a squared plus 3a plus 2. So basically, this inner part represents what is the function being represented by. So
So
if
there's-
I were to take this one level up, I would say if I
so there's
fx is equals to 2x squared plus 3x plus 1, what should be f?
so there's so there's
Instead of x, I'll just write 3x squared plus 2 equals to. So I would write, instead of x, I just replace 3x squared
so
plus
there's
2
so there's
whole
So there's-
squared plus 3x, 3 multiplied by 3x squared plus 2 plus 1. So basically, what this inner term tells us is what we are representing as the unknown or whatever it is. So whatever is inside the function bracket tells us what we are going to replace it with. So now, if in the same example, we have something like
so there's
f. Okay,
So there's-
now let's say we have this as fx, and then we have this as gx, which would be this. Gx is equals to
there's-
3x plus 2. Okay, just assume it for now. Now, if I were to write a question which gives us f, and instead of x, they just write gx inside it.
So there's
Okay.
so there's so
F
there's
gx.
so there's so there's
Okay.
so there's so there's so there's
Let me just clear this.
so there's
Okay. So that would basically mean that we have
so there's
the
so there's
function gx inside the function f. And that would basically mean I would just write down gx inside fx. So we have fx is equal to 2x squared. Just let me erase this one for no confusion. So basically, we have fx is equal to 2x squared plus 3x plus 1. So 2. And then we'll copy down, instead of x squared, I'm going to write the function gx. So 3x plus 2.
so there's
Whole squared plus 3 multiplied by 3x plus 2
so there's
plus 1. And that's basically what that means. So now if they're telling us something like
so there's so there's so there's
f
so there's
squared x, this means that they're telling us that we have input f into fx.
so
Okay?
there's
So we have basically the input fx 2 times into the same function.
so there's
So now which one is supposed to be in the main light? It's this one.
so
2x
there's
squared minus 4.
so there's
Okay.
so there's so there's
Now what I'm going to do is input fx into f. So that would give me, if I were to just copy down fx, fx is
so there's so there's
change the 2x squared minus x minus 4. Now input 2x squared minus x minus 4 again. The 2, instead of x squared, just write 2x squared minus x minus 4. And then instead of x, we write minus 2x squared minus x minus 4 minus 4. Okay, so now let me just add this square here. So now 2 multiplied by
so there's
2x squared minus x minus 4 would again be simplified. 2x squared minus x
so there's
minus 4.
so there's so there's so there's
in fact, what I'm going to do is one method. I'm going to first, because just to keep things clean, I'm first going to find out
so there's so there's
square
so there's
of 2x squared minus x minus 4 whole squared. Just to keep things clean, you can just solve directly as it is, but I'm first going to individually find out 2x squared multiplied by 2x squared minus x minus 4 minus x multiplied by 2x squared minus x minus 4, and then minus 4 multiplied by 2x squared minus x minus 4. Simplify this, we get 4x raised to power 4 minus 2x raised to power 3 minus 4 to the 8x squared minus 3x, minus 2x raised to power 4, the 2x raised to power 3 plus x squared plus 4x minus 4 to the 8x squared plus 4x plus 4. 4 is 16, sorry. Simplify this further, we get 4x raised to power 4. Then we have negative 2x cubed minus 2x cubed would give us negative 4x cubed minus 4x cubed here. So there's 8x squared minus 8x squared negative 16x squared plus 1 is equal to negative 15x squared. So negative 15x squared here. So the next thing is 4x plus 4x is equal to 8x plus 16. Now I can just write this, continue with question. And I can just input this value in 2 multiplied by 4x raised to power 4 minus 4x cubed minus 15x squared plus 8x plus 16 minus 2x squared minus x minus 4 minus 4. Okay, now 4 2 is 8. 8x raised to the power 4 minus 4 to the 8x raised to the power 3 minus 30x squared plus 8 to the 16x plus 16 multiplied by 2 is 32 minus 2x squared is minus 2x squared plus x plus 4 minus 4. for this one, first let's just square this up. So this is 15 multiplied by 2. This is 30x squared. Just check if everything else is fine. 8 to the 16 plus 16 to the 32 minus 2x squared plus x. Okay. So now we are going to just copy 8x raised to power 4 as it is. Negative 8x cubed is going to be again copied down as it is. Negative 30x squared minus 2x squared would give us negative 32x squared. And then we have positive 16 plus x, which would be positive 17x, and then 32 positive 32 is equals to your answer. Just let me check this up. 8x raised to power 4 minus 8x cubed minus 32x squared plus 17x plus 32 is your answer for part C. For part D, we are going to just say gfx, which would mean, we are, again, as in the previous exercise we discussed, this would mean we input fx into gx. So we already know gx, write down gx, x squared plus 5x plus 2. Now we input fx into this. So we know fx is 2x squared minus x minus 4. So instead of x squared, I'm going to write 2x squared minus x minus 4 multiplied by 2. Sorry. Whole squared plus 5 multiplied by 2x squared minus x minus 4 and plus 2. Okay. Again, 2x squared minus x minus 4 whole squared. We've already found this out. I mean, as we're doing some exercise questions, I do have the ability of taking some things. So we'll just take this up and we can say 2x squared minus 4x minus 4 is equals to plus 5 multiplied by 10x squared, 5 multiplied by 2x squared is 10x squared minus 5x minus 20 is 2. I'll simplify this. 4x raised to power 4 is going to be written as it is. In fact, I'm going to just remove these brackets because they're unnecessary right now. Okay. So next up, we have 4x cubed. That's going to be written as it is. Negative 15x squared plus 10x squared is going to give us negative 5x squared. Plus 8x minus 5x is going to give us what? 8 minus 5 is 3. So this is going to be positive 3x plus 16 minus 20. In fact, plus 18 minus 20. So this would give us negative 2. And that's it. This is your answer for part D. 4x raised to power 4 minus 4x cubed minus 5x squared plus 3x minus 2. And that's your answer. And that is it for this chapter, for this exercise 3.1. I'll meet you in the next lecture. I hope you understood what I meant by the changing my book thing. But this is it. From now on, we are going to follow CU Pemberton's at O-level and IGCSE additional mathematics third edition, so that future students can easily benefit from my lectures. The first two chapters will stand there because the first two chapters are exactly the same, I guess. But yeah, the concept, most of the questions are same. The chapter 3 of the previous exercise I've uploaded, I'll change the names to just indices and surds so that you will have easier knowledge to understand that. So I hope everything's clear. And I'll meet you in the next section. Thank you.